Hi, in this video we're going to look at insertion sort. And insertion sort, if you think about it like, let's say that you have a deck of cards and you want to put them in order. So you would look through the cards and you would find one and then you would stick it in the right slot where it would go, and then the next one and so on. So this one's a little bit different. Um, I'm not going to do a demonstration on this one because it's kind of complicated on that. But as I go through and we create this, I'll kind of explain kind of what's going on here. So let me do an import random so we'll have that available to create our list. So def insertion sort a list. Do a for loop for index in range 1 through the length of a list. Current value is going to be equal to a list right here, index, and position is going to be equal to index. Okay, so it keeps track of both, keep track of the value and where it's located. So while our position is greater than 0 and a list position minus 1 is greater than current value, a list position is going to be equal to a list position minus 1. Okay. So as long as our position, which we set to index, okay, is greater than 0, so the first time through, our index is going to be 1, so it will be greater than 0, and a list position minus 1 is greater than the current value. Then it will set a list position equal to a list position minus 1. Okay, so that'd be that value there. And then position will be equal to position minus 1. That's where it's located. Once we get done with the while loop, a list position will be equal to current value. Okay. So what this is going to do is going to go through, and every time it finds position greater than 0 and a list position minus 1 is greater than our current value, it will figure out where that's located in there and get the position and the value. And then when the while loop breaks, then it's going to do the swap on there. Okay. So we'll put some code in here to test it out. Its performance here in a little bit. Okay, so we're going to do the same thing in here, and give me just a second. Okay, so in our main here, then what we're going to do, and I'm going to need to put time up here. Oh. Actually, let's test it out first. Let's just put in a list here. Well, no, we'll do it this way. We'll test it out with this. So we're going to do a for value in range num. So I'm going to need to put some variables up here. List is going to be equal to an empty list, and num, I'm going to start it off, is going to be equal to 10. And I got value spelled wrong there. Won't matter until I spell it right down below here. So, okay, so what I'm going to do here is print just a little header here for this, and then for value in range, num list dot append value. Then random dot shuffle list. Okay, since we're only running at runtime for 10, I'm going to go ahead and print list out here, and then we'll do our start time. We'll call our insertion sort passing in list. We'll do our end time, and then we'll print our time. Okay, so let's see if I got all this stuff in here right. Go ahead and save this. Call it insertion sort. .py. And let's run it and see what errors like happen to get in here. Okay, so it printed, but I did this for it to do it 4 times. Or no, I didn't. For num, may have my print in the wrong place here. Oh, here we go. Let's change this down to 1. Error position. Nope, this is going to be the okay, I think oh, no, I had this right. Okay. I need to change this here to 10, because this is what's creating the list there. And then this is how many times it's going to run. Oops, it didn't like that. Oh, got a position up here spelled wrong. Right there, the I out. Another one in the while loop. Go. Got another one in the A list position equals. A lot of I's out of my positions. There we go. So we had 10 values. That's the list. I did not print it afterwards. Let's print it here. There, run it again. Okay, so there's the two lists. There's the list mixed up, and then there's the list sorted out. Times is 0, 0 because we only ran 10 numbers. It goes really fast. So now what I want to do is modify this. I'm going to leave num equal to 10. I'm going to run this 4 times. This is going to be num here. So that's how many we're going to create. And then inside the for list here, let's see here, this stuff here, let me back up. I'm going to indent all this inside this outside for loop. And then num equals num times 10. Okay, let's run this and see what happens. Oh, I got those print statements in there. When we get up to 1,000, 10,000, it's going to print a lot of numbers, so we want to take those out of there. Okay. So there we go. We have value size 10, time was 0. Value size 100, time was 0.001. Value size 1,000, 0.1. Value size 10,000 took 9 seconds. Okay, and I think I got these backwards. Yep. That's why we get negative numbers there. So n minus start. Okay, the next thing I want to do is I'm going to put in some compare and exchange. Compare equals 0 and exchange equals 0. This is the compare in here. Okay. And then this is the exchange. So I've got to put the compare inside here. And then the exchange right after this. And then when we get completed, then we'll print both of these. Okay, and then down here, right in here, I'm going to put a print statement. Hopefully I get the print in the right place there. So let's run this and see what happens. Exchange, not exchanges. Exchange, yep, there we go, okay. Okay, so for 10, we had 26 compares and 9 exchanges, 0.03 seconds. For size 100, our comparisons went way up, our exchanges went up, time went up, or time stayed about the same. Okay, when we did 1,000, we had 300,000 comparisons, 1,100 exchanges, and it went up to 0.1. And then when we did 10,000, it went up to 11 seconds. We had over 3 million comparisons and 11,000 exchanges. So a lot more comparisons, but a lot fewer exchanges in this one. Okay. So compare this one with the other ones. We're still at n squared, because if you look at this, we have a for loop and then we have a while loop inside of here. Now, while this could break out sooner, it doesn't really. It still has to go through n times and n minus 1 times as you go down through here. So it still comes out as an n squared. So not a real efficient sorting technique for large sets of data. Okay? So Hope you got something out of this one, and I'll continue on with the next one later on. Bye.